Welcome to my YouTube channel. In this video we will see heterocyclic compounds, classification and nomenclature. So heterocycles containing nitrogen, sulfur and oxygen. So these are important as per your syllabus. So this topic it is from Pharmaceutical Organic Chemistry 3 and also it is required for PharmD students. Let us see the definition of an heterocyclic compounds. What are heterocyclic compounds? So when there is a carbon chain, so this carbon chain, it contains some heterocycle. For example, so this can be a carbon chain, but if it is containing a nitrogen in between, so that kind of compounds are said to be an heterocyclic compounds. So heterocycle means there is one heteroatom, like this we can say it is not an heterocyclic compound, it is a benzene. So there is no heterocycle in that case, but if in case of an carbon, if here it is having a nitrogen, then it becomes an heterocycles. And mainly we will see the compounds containing an heterocyclics, they are oxygen, nitrogen and sulfur. This is the classification. There are almost 7 classes as per the syllabus. First is oxygen containing rings. So again there are categories 5-member rings and 6-member ring, Purine and Pyrene. Nitrogen containing, that is 5-member ring, pyrrole, pyridine and azapine. 5, 6, 7 ring containing. Sulfur containing 5-member ring, thiopane and 6-member ring containing thiopyrene. Oxygen, nitrogen containing ring, again 5 members and 6 members. Oxazole and 1 for oxazine and morpholin. Oxygen and sulfur containing 1,3-oxathiolene and 1,4-oxathine. Sulfur, nitrogen containing thiazole, 1,4-thiazine. And next, last class, that is benzo-fused heterocyclic compounds. So they are benzimidazole, benzthiazole, benzpyrrole, purine, isoquinoline and quinoline. So these are some of the classes. If you see the classes, see first class it contains a heterocycle, that is oxygen. It contains oxygen. Second it contains nitrogen. And third it is sulfur. So these 3 are very important as per the syllabus. And next it is oxygen and nitrogen. So oxygen and nitrogen it will be. Then oxygen and sulfur it will be. And the next class, that is sulfur and nitrogen. If you see, it is a mix of only these 3 heterocyclic compounds, that is nitrogen, oxygen and sulfur. And last it is benzo-fused. So benzo-fused means it will have a benzene ring and it is fused with these cycles. All these cycles that will get fused with the benzene. Now we will see the structures of an heterocyclic compound. 3 important structures they are. So the first structure, it is of an nitrogen containing. So it is pyrrole. Next is, it is oxygen containing, that is called furan. And the third very important structure, it is of a thiopane. If you see the valencies of each heteroatom, nitrogen it contains 3 bonds always. So 1, 2 and 3, there are 3 bonds. Oxygen it will have 2 bonds and sulfur will also have 2 bonds. So the valencies are completed and it is having a double bond. This structure it is called thiopane. Now how to start a numbering? Numbering usually it starts from the heteroatom. It starts from a heteroatom. So numbering will start from this side, 1, 2, 3, 4, 5. You can start numbering from this side also, because there is no substitution from any side. You can start the numbering. When there will be a substitution, so at that time you have to start a numbering from the closest number. Again here 1, 2, 3, 4, 5. As we know the rule that we have to start a numbering from an heteroatom. So this is the numbering from an heteroatom. Now next is, we will see the most of the structures they are related with the nitrogen only as per the syllabus. They will contain 2 nitrogens. They will contain the 2 nitrogens. So the next structure, it is containing 2 nitrogens. And these 2 nitrogens, one of the nitrogen it is having a hydrogen and one of the nitrogen it is not having a hydrogen. Now from where to start a numbering? The name of this structure, it is imidazole. Imidazole. So zole, always remember that zole, when it is written in the suffix, it means that it is containing in the nitrogen. We will see in certain examples. 1, 2, 3, 4, 5. So this is the right numbering. We have to start numbering from the nitrogen which is containing the hydrogen. We cannot start numbering from this nitrogen. Now the next structure, it is of an pyrazole. Pyrazole, again you remember that it is containing a zole, it means it is containing the nitrogen, and pyrite refers to again a nitrogen. So as we have written here a pyrrole, again pyrazole. Now the next structure of an pyrazole, there is only a little bit difference, that in case of an pyrazole, nitrogen it is at a second number position. Double bond, it will be as it is like in previous structure. Only the difference is that it is having the nitrogen at a second number position. It can be called as an iso position also. We will see in certain examples of an iso position also. The next structure, it is of an thiazole. Again remember that zole, it means nitrogen, and thia, it is for an sulfur. Sulfur and nitrogen, it is containing sulfur and nitrogen. So the structure, it will be like this, that it will have a sulfur atom and it will also have a nitrogen atom. And remember, when it is written only a thiazole, it means it is containing a nitrogen at a third position only. Like here, numbering will start not from the nitrogen. Numbering will start from the highest priority atom, that is sulfur. So sulfur, we will start numbering from in sulfur. Sulfur will have a number 1, 2, 3, 4 and 5. You cannot start numbering from this side, because the numbering for the nitrogen, it will become 4. Once you start from this side. So this is not correct, because we have to find out the heteroatom which is closest for a numbering. Next structure, it is an oxazole. Oxa, it again refers to an oxygen, and zole, it refers to a nitrogen. So the numbering, the number of a nitrogen, it will be again and 3, and oxygen, it will be at the first position. So numbering will start again from the heteroatom which will have an highest priority. Why it is having a highest priority? Because the atomic number of an oxygen, it is high. Nitrogen 7, oxygen 8 and sulfur, it is 16. So always remember that heteroatom with the highest priority will start numbering. 1, 2, 3, 4 and 5. We cannot start numbering again from this side, because we have to choose a heteroatom which is closest by the numbering. Next, they are same examples of an thiazole and oxazole. The name of the compound is, suppose the name is isothiazole. Iso, it refers to the second number position. Second, thia, it refers to a sulfur, and zole, it refers to a nitrogen. So it will have a position of an nitrogen at second number position. So they will be always referred as an iso. We are having a further structure of an isoquinoline also. So that also time you remember that iso, it means position, it is at a number 2. Numbering will start from this side, 1, 2, 3, 4 and 5. After that, the next compound, it is isooxazole. So isooxazole, it refers to the compound that it is having a numbering at 2. Oxide refers to an oxygen, and zole, it refers to a nitrogen. Again we will write a structure. There is only a difference that in this structure the nitrogen, it is at a third number position, and in this case nitrogen, it is at a second number position. So this will be the structure. Numbering will start from heteroatom, that is oxygen, 1, 2, 3, 4 and 5. From whole, you might have understood that nitrogen, when it is in the 5-member ring, it will be written as an azole in the suffix all the time. You will see everywhere zole, it means it is an nitrogen, and thia, it means it is sulfur, and oxide means it is an oxygen. Only this name, it is little bit different, that is furan, and all they are 5-member rings. Now we will see the compounds, heterocyclic compounds from a 6-member ring. Very first example, as per the syllabus, it is a pyridine. So pyridine, it will have the 3 double bonds, and see there will be again a lone pair on the pyridine. Now it is very simple from where the numbering will start. So numbering will start from the heteroatom, that is nitrogen 1, 2, 3, 4, 5, 6. As there is no substitution, you can start from any side. Next, it will contain the two nitrogens. It will contain the two nitrogen in that case. So nitrogen will be two very important structure, that is, it is of an pyridine. So again, in case of an pyridine, there will be no nitrogen. It will be without an hydrogen. Again, we can start numbering from any heteroatom, that is nitrogen. So we will start from here 1, 2, 3, 4, 5, 6. The name of this compound, it is pyridine, and this it is pyrimidine. It is pyrimidine and pyridine. So din, it will refer to an nitrogen. Now there are some more compounds in same class. One is it will contain the heterocyclic 6-member ring, but the nitrogen position it will change, and the change in the position, it will be at an 4th position. So the 1, 2, 3, 4, 5, 6 as per the numbering, and the name of this compound is pyrazine. The name of this compound is pyrazine. So zin and zol, as you can remember that zol, it was for 5-member containing nitrogen, and zin, as in it is for an 6-member containing a nitrogen. Pyra, it means nitrogen, and zin, it is again a nitrogen, but it is for 6-member. There is one more example in this category that it contains a nitrogen. You can see the position, these positions they have filled now. The position number 3 and position number 4, only the remaining it's position number 2. So nitrogen, when it is at position number 2, we will start numbering from any heteroatom because there is no substitution. Name of this compound, it is pyridazine. Zin, it refers to an 6-member heterocyclic compound, and nitrogen means, and pyra means again it will be a nitrogen. This was about 6-member containing the nitrogen, heterocycles containing 6 nitrogen at 6. Now the next is 7-member containing ring. The name of structure, it is azapine. It is azapine, and the structure for azapine, it is 7-member. So I will draw it. It is also containing a bond. So azapine, 1, 2, 3, 4, 5, 6, 7. This is the numbering for an azapine. There are 7. It is 7-member ring, and remaining rings, they are 6-member. Now you understand that zol, it refers to an 5-member containing nitrogen. Zin, it refers to containing 6 heterocycles containing 6-member containing a nitrogen, and pine, it refers to a 7-member. Now we will see some of the examples from the class of and fused heterocyclic compound, but before that we will also see some of the fused heterocycles which are related to the nitrogen only. Very famous example, it is of an quinoline. For that purpose, you need to understand. I will write here one of an example, that is, suppose we can write this example. It is fused heterocycle with an benzene ring. Nitrogen will not have a bond because already the bond has been satisfied. Only see the bond positions. For this, I will number it, and the name of this compound is very important. The name of this compound is, see, it is containing benzene ring, and the next ring, it is of an pyrrole. So it is called benzpyrrole, or commonly it is called indole. You will always see that this ring, it is called indole commonly, and the correct name, that is benzpyrrole. And numbering will start again from an heteroatom, that is from the nitrogen 1, 2, 3. Don't number this carbon, leave it 4, 5, 6, 7. So there are only 7 carbons. Numbering it is only for 7 carbons in this case. Now the next it is benzpyridine. It is benzpyridine. In case of an benzpyridine, it can be the common name for this compound, it is because benz, it is for benzene ring, and pyridine, it is for an pyridine ring. So the common name for this compound, it is quinoline. It is quinoline. Usually you will see it is not written as benzpyridine, but it is written as an quinoline, like an indole. Numbering will start from this heteroatom nitrogen 1, 2, 3, 4. Leave the bridge carbon 5, 6, 7, 8. So these are the correct numbering for an quinoline. Next structure, it is of an isoquinoline. I will write it here, isoquinoline. Isoquinoline. Iso, already I have told you that iso means at a 2 number position. So here there is little bit an exception in case of an heterocyclic numbering, that numbering it does not start from the heteroatom. Like as we have seen, the nitrogen, it is at this position, and there will be a carbon, 6 member ring, both the 6 member ring they will be. Now just put the bonds. Numbering it will start from the heteroatom. So numbering it will start, it will not start from the heteroatom in case of an isoquinoline. It is one of an exception. Numbering will start as like an quinoline only, 1, 2, 3, 4, 5, 6, 7, 8. So these are only the 8 numbering for an isoquinoline. In the last slide we have seen fused benzene ring cycles. So it is now the next compound. The structure, suppose it is like this one. You know that this ring, it is an benzene ring, and the remaining ring, it is of an imidazole. So the name of this compound, it is benzimidazole. As this ring, it is an zole, means it is nitrogen containing 5 member ring, and it is 5 member ring imidazole ring, and which is fused with the benzene ring. So the name of this compound, it will be benzimidazole. So numbering will start from the nitrogen which is containing the hydrogen 1, 2, 3, 4. Leave this bridge carbons 5, 6, 7. Now the next is the, for an example, the name of the structure, it is benzthiazole. So thia, sulfur, and zole, it means nitrogen with an 5 member ring, and benz means it is an benzene ring. So we can write it as benzene plus, as it is thiazole, 5 member ring. So the name of this compound, it is benzthiazole, and numbering will start from the sulfur 1, 2, 3, 4, 5, 6, 7. For example, the name of the compound, it is benzoxazole. It is benzoxazole. So zole again for 5 member ring nitrogen, oxa it is for oxygen, and benz it is for benzene. So we will draw the structure based on the name benzene, 5 member ring containing the nitrogen. Now it will have oxygen at the end, and this will be the final structure. Oxazole, numbering will start from the oxygen 2, 3, 4, 5, 6, 7. So these are some of an examples of an fused heterocycles. There is one more example of an fused heterocycle where there are 2 benzene rings attached, and these 2 benzene rings, they are attached to the nitrogen, means it is having a pyridine ring in between, and there are 2 oxygen ring, sorry, benzene ring, they are attached with this. See that all the carbons, they will have association with a double bond. they will have association with a double bond. I have written little bit mistakenly over here. So there will be only one single double bond connected to an each carbon. So check that. So there are almost 5, 6, 7 bonds in the ring. Numbering will start again. There is exception in this case also, that numbering, it does not start from the nitrogen. It will start from the carbon 1, 2, 3, 4. Leave this carbon in between 5, 6, 7, 8, 9, 10. So the last will be an heteroatom, and this structure, it is of an acridine. This structure, it is of an acridine. There are some exceptions in case of an heterocycle, that all the rules of a numbering, they are not similar for all the heterocyclic. Like we have seen isoquinolone, it is starting from carbon number 1, not from the nitrogen. Similar way acridine. And there is one more structure in which the numbering, it does not start from an what it has been predicted like a nitrogen. So the numbering, it starts from a different heteroatom. This is the structure of an purine. So the purine structure, it will have a bond here, again a bond here, again a bond here. See that, make a correction in the bonds wherever they are available. Next is now the numbering. In this case, numbering, it starts from the nitrogen, but not from this nitrogen which is containing hydrogen. Usually we have seen in case of an heterocycles, it is one of an exception because it contains a nucleotides and nucleosides, and also it contains an amino group. So that is the reason that numbering, it does not start from this nitrogen. But overall, you just understand that numbering from where it will start. And there is also a difference in numbering of a bridge carbon also. 1, 2, 3. We are usually seeing that we leave this bridge carbons, but in this case 5, 4, 5 and 6. So this will be the number for this pyrimidine analog, and remaining, it is imidazole analog. It will have numbering, again it will start from, so it will be 6, here it will be 7, 8 and 9. So this will be the numbering for a purine molecule. It is having a different numbering, as well as we don't consider the bridge carbon while the numbering, but in this case numbering, it is different. You can read it from the Google why it is having a different numbering. There are few heterocycles remaining. Out of that, 6-member ring containing an oxygen. So there are examples of this ring also, but it is not containing a bond here. And the name of this compound, it is Purine. Usually we have seen that Purine means it is containing a nitrogen, but in this case it is an oxygen 6-member ring containing. And numbering will start from the heteroatom, and numbering you have to start from the dihetero where there is a hydrogen. So it will be 1, 2, 3, 4, 5, 6. Don't start numbering from this side. Start numbering from this side, but usually we have seen that the double bond has the highest priority than a single bond. But again, there are some exceptions in case of an heterocycle, and the name of this component, it is 2H, because there is one H hydrogen extra at an second position. So the name of this component will be 2H pyrene. In case the name, it is 4H pyrene. With 4H pyrene, it means that there is one extra hydrogen at an fourth position. So as you can see the structure 1, 2, 3, 4, there is at fourth position there is an extra hydrogen. There is no double bond, it is an sp3 hybridized carbon. It was about 5-member ring containing an oxygen. There is one more, that is 6-member ring containing an sulfur. So 6-member ring containing an sulfur, it is having the same kind of an bonding, like the bond, if it is not at an 2 position, means this is an sp3 hybridized carbon. The name for this, it is thiopyrene. It is thiopyrene. So thio, it refers to sulfur, and pyrene, it refers to that ring. And the name for this, it is 2-thiopyrene. If it is 4H thiopyrene, so 4H thiopyrene, it means that it will have sp3 hybridized carbon at fourth number position, as we can see 1, 2, 3, 4, 5, 6. So it will be 4H thiopyran. The few examples that they actually, some of the examples they are not in the syllabus but they are in the classification, because the classification it has been asked. Oxazole, already we have learned about an oxazole. So oxazole we have learned it. Isooxazole also we have learned. Oxadiazole. So oxa, it refers to oxygen, and diazole it means that it is containing 2 nitrogens. So the structure will be like this. Oxadiazole, and numbering it will start from this, and so it will be 3,4 oxadiazole. Nitrogen can be at this place also, so it will be 3,4 oxadiazole. Now next is 6-member ring containing oxygen and nitrogen. So 6-member ring containing 1,4, it refers to an positions of an oxygen and zin. Zin, actually we have seen that it is a nitrogen containing in the 6-member ring. So oxygen and nitrogen. Numbering will start from the position, that is oxygen 1, 2, 3, 4, 5, 6. So 1 and 4 oxygen and nitrogen. 1, 4 oxazine. Morpholine is the same structure, but morpholine does not contain any bond. It will contain the hydrogen, and numbering will start from again oxygen 1, 2, 3, 4, 5, 6. It does not contain a bond, and it will contain a hydrogen on the nitrogen. And here also it will contain the hydrogen. I missed that. So these are the structure of an 1,4 oxygen and morpholine. There will be no double bond in case of an morpholine. Again there is a structure of an oxathiolene. So oxathiolene, it refers to the ring. In both the structure, that is oxygen and sulfur containing, it will not have a ring. So this will be a 5-member ring. 1, 4, 1, 3, it is oxathiolene. So there will be sulfur at the first position and oxygen at this position. So there will be no double bond in this case. Numbering will be start from sulfur, highest priority atom. So this is the structure of an 1,3 oxathiolene, and 1,4 oxathiene. Again it will be a similar structure but with an 6-member ring. Sulfur and oxygen. There will be no double bond in this case. Numbering will start from this 1, 2, 3, 4, 5, 6. And in some cases it is written as like double 6 bonds on the oxygen also. So that is also correct, that the valency of an oxygen, it is sulfur, it is 6, so it can be written as double bond, that is sulfur containing. But usually you don't prefer it to write, just write to prefer only a sulfur instead of that. Thiazole, already we have seen this thiazole. It means it is containing, zole means nitrogen and sulfur. So this was the structure that we have seen already. Now this 1,4 thiazine, 1 and 4, so there will be nitrogen at an 4th position, as it is 6-member ring. Zin, it is for the nitrogen containing the 6-member ring, and there will be a double bond in between these two only. And numbering will start from sulfur 1, 2, 3, 4, 5, 6. And we have seen all these structures, that is indole, benzimidazole, thiazole, benzoxazole. Only there is a new structure, that is benzpyran. So this benzpyran we have seen already, that is containing and 6-member ring containing an oxygen. So this was only the different one. The double bond position in case of this, it was not correct. So again I will write it. Now this is the correct structure. Numbering, it will start from this 1, 2, 3, 4, 5, 6, 7, 8. So this is the structures of an benzpyran. And remaining structures we